So today we're going to be going over the chemical reaction types and equation notes, specifically the synthesis reactions. So first things first, let's just define what a balanced chemical equation is. I hope you can see this okay. So a balanced chemical equation is just when both sides of the equation have the same number of atoms of each element and mass is conserved. Coefficients are used to balance. Okay, so we know that a chemical equation just uses the formulas and symbols to represent the reactants and products. A balanced chemical equation, same thing, but we're just ensuring that we have the same number of atoms on each side. So today we are specifically going to be talking about synthesis reactions. Okay, synthesis reactions are pretty straightforward and hopefully you get them pretty quickly. So let's define what a synthesis reaction is. So a synthesis reaction is when two or more substances combine to form one product. So it's when two or more substances combine to form one product. And these reactions are always going to follow the pattern of A plus B yields AB. And now note, let me get a different colored pen here. Please note, that was already open, that the element that is first in the compound will always have a positive charge, and then the second element will always have a negative charge. Okay? So for our example, we have solid aluminum and solid iodine are being mixed together in an evaporating dish with a few drops of water added. Aluminum oxide is formed. So first things first, we need to write our skeleton equation. So we have solid aluminum. Aluminum, looking at our periodic table, aluminum is Al. So we're going to write Al. And it is a solid. So we're going to write the state of matter in parentheses next to it. Okay? Aluminum and solid iodine. Again, looking at our periodic table, iodine is right here. It is I. It has a circle around it, this circle, meaning it is one of our 7 diatomic elements. So when we write it by itself, it needs that baby 2. It has a circle, it's diatomic, it needs that baby 2. And that is also a solid. So they're mixed together in an evaporating dish, and a few drops of water are added. So water in this instance is going to be our catalyst. So whenever we have a catalyst present in a chemical reaction, we're going to write that above our reaction arrow. So we're just going to write H2O above our reaction arrow. And finally, aluminum oxide is formed. So going back to our naming and writing binary ionic formulas, we know that aluminum has a +3 charge. I'm so sorry. This should not say oxide. This should say aluminum iodide. Again, I told you guys, I always have typos. So aluminum iodide is formed. So still aluminum has a +3 charge. Iodine, on the other hand, has a -1 charge. So we're going to switcheroo our charges. So our I will get a subscript 3. So you can just leave these charges here, or you can just cross them out so you don't get confused when you're balancing. And this doesn't tell us what state of matter it is, so we're not going to worry about it. So now, this is our synthesis reaction. We have written the reactants and the product. Now all we have to do is balance. So I have 1 aluminum and 1 aluminum, so they're good. 2 iodines and 3. So when we have 2 and 3, we need to get to 6. So to get 6 iodines on my product side, I'm going to be adding a coefficient of 2. That impacts my aluminum. So I'm going to balance my aluminums here. Okay, so I have 2 aluminum, 2 aluminum. Good. 6 iodine and only 2 here. So a coefficient of 3. 3 times 2 gets you 6 is required. All right, so that is our balanced chemical equation for our first synthesis reaction.